For decades, rockets have been launching into space, taking payloads and satellites and humans. In fact, I came up to space on top of a rocket in the Dragon. It looks like this little model. But each of those times that has happened and we've gone to space, the rocket launches and it uses almost all of its fuel to get the payload into orbit. The rocket falls into the ocean, or now we have some new companies now that are making rockets that save a little bit of that fuel to come back and land on Earth and be reused again. But for the most part, rockets use all of their fuel. They go to space, and the only place that rocket could get fuel is on the Earth. Now, there are some small exceptions. The International Space Station, we have a Progress cargo vehicle that launches and docks with the space station and transfers some of its fuel to the space station so we can use it for maybe reboosting our orbit a small amount or maintaining our pitch attitude, yaw attitude, or roll attitude relative to Earth. And that's super important, but that's a very small amount of fuel that we get transferred up here. We're not doing big things. And by big things, I mean go to the moon and go to Mars. And so as part of the Artemis program, we have an architecture whereby a large starship is going to launch and go to space and meet another starship, and they're going to connect, and they're going to transfer fuel from one starship to the other. And then that one of those starships is going to disconnect, go back to Earth, and it's going to go back and forth each time up into space to refuel this mothership full of fuel. And once that mothership is full, it'll transfer its fuel to another starship, a special starship, and this starship goes to the moon. So it'll launch from Earth, it'll come up and suck all that fuel out of the mothership, and then it'll go off to the moon, be met by the Orion spacecraft, where then they can then take that starship down to the surface of the moon. And so before launch, I was thinking quite a bit about this, and I thought I would bring up some demos and some experiments that I could use to explain some of the difficulties there are in transferring a fluid from one place to another. And so hopefully, as you see, we go through these experiments with the help of Dawn, you'll see some of our struggles making these happen, and imagine how you would do this on the scale to go to both the moon and to Mars. All right, today we're going to simulate our rocket ship with this bottle of water. And the water in there is going to simulate our rocket fluid, and you can see the gas bubbles in there. And so if you had a rocket engine and you're fueling it with rocket fuel, you don't want a gas bubble to go in to your rocket engine. So to prevent that in space, as you can see that floating around, different spaceships handle that in different ways, but it's pretty common for spaceships to do something called a settling burn. And they take this little bit of fuel that's right here near where let's say the fuel is going to go into the rocket engine right here. And they do a little burn, poof, they push it a little bit. And when they do that little push, it pushes the rocket fuel back towards the nozzle. And so we're going to simulate that today with water as our rocket fuel and our gas bubble in here, letting this pressurize. And the first thing we're going to do is we're just going to let it shoot a little bit, and you'll see a little bit of gas comes out and it won't really accelerate a whole lot. And then maybe we'll do a settling burn, simulate a settling burn by pushing a little bit, get all the water this side, and watch our rocket take off. Don, I'm glad you're here to help contain my mess.
I'm running the towel.
You got that one?
I got it.
We got it.
Shove up.
Ready, go. Okay.
Okay,
let's clean off the outside.
Yeah.
We're gonna let the pressure build up with the lid off.
Oh, yes.
And then, whoa. We got good audio. So, all right, we're gonna try this again. Don's got a new shirt. We want to demonstrate why you do a settling burn. So the first thing we're gonna do is we're gonna have it shoot just gas. Just gas. Ready? Go. Okay. Okay. So we don't have any fluid anywhere near the nozzle, and the Alka-Seltzer is just shooting gas, and you can hear it. You can hear it just puttering along. Okay. Now we're gonna give it a settling burn to get some of that fluid there. Don's gonna protect himself. There we go. Yeah, that's a good one. One more here, coming back in. Get the fluid at one end. Yeah! All right. Top gas.
That is good.
So I was at SpaceX in training, and I saw these water bottles, and these water bottles come up in the Dragon. It's what we use to drink. That's what we get our water to drink from on the Dragon. We're coming up to the space station and going back down to Earth. And I was looking at them, and I was looking at a picture of Starship, which is, we're going to launch as part of the Artemis program. and that's going to go up into orbit. And the Starship's going to go up into orbit, and we're going to send up a mothership for fuel, and then other Starships are going to go up and give it fuel, and give it fuel, and give it fuel. And then finally the lander is going to launch from Earth, dock to the mothership, take a whole bunch of fuel, and then go off to the moon, and then dock with Orion and go land on the moon. But I was thinking, well, how are we going to transfer fuel from one spaceship to another when the fluid, the rocket fuel, is inside bouncing around? You kind of want to get it all to one end so your pipes can suck up that rocket fuel and transfer it someplace else. And so I was thinking, well, if you have, let's say this one just launched and it's full of fuel and it wants to give fuel to the empty rocket ship, you got all these bubbles in here. Wouldn't it be cool if they docked like this, and then they could rotate about each other, and the rotation here puts all this fluid, all the rocket fuel, to one end, like this, so your pipe, if you're picking up the fuel, can pick it up. So what we've got is, let's pretend this is one spaceship and this is another. We're going to transfer fuel from this one to the other one. We have a little pipe on the inside, and then we need to pressurize this side. So rockets move fuel or pressurize their fuel to get it to the rocket engine by pressurizing with gas, typically helium. And so we're going to use Alka-Seltzer in the water to pressurize this tank, push the fluid through the pipe, through this adapter that we 3D printed into this side. And the extra gas in this side is going to come out a tiny little hole we have right here. Hopefully it doesn't shoot rocket fuel at this. Hopefully not at Don, hopefully not at me. But the idea is to spin this and have it transfer one while we have this one pressurized. And what'll be interesting is, if we don't do that spin maneuver, we should just be pushing Alka-Seltzer gas through here. And if we do the spin maneuver, like this, we should be able to get rocket fuel transferring.
And we've never done this
We've
before.
never done this in orbit before. I did, full disclosure, I tried this on the ground, not spinning and not in 0G. So you might have a bit of a disaster here and watch Don and I make a mess of ourselves, but I think that's part of the fun.
Oh, I'm taking my glasses.
Taking the glasses off. Ready? Get in there, go. I got the towel.
Okay.
Go, spin, tighten it down. We're good. Okay. What could possibly go wrong? All right, we're already transferred fuel. I can see it. But what's interesting to me is the center of gravity might change as we transfer fuel from one to the other. I think it's working. Oh. It's tough to kind of find which part to hit because you can't hit the center of mass. Oh, towel. We're losing it out of the gas port. Hold on. Let's see here. All right, I'm going to spin it really fast and cheat a little bit so we can get the fluid away from the gas port.
Okay.
And now we're kind of equaling the center of mass, and we're pumping fluid either way. And you see the center of mass changing as it pumps fluid from one side to the other. I'm going to get it going again. We want to spin it fast like this to get the gas away from the port. We should have made one of these visually significant.
Well, you got water in it.
So the one with more water now, I think, is the tank. All right, we're leaking from the gas ports.
Fun all
I'm hoping our first Starship propellant transfer is a little bit more controlled than that.
Subscribe for more space.